So today let's study chapter 2 solution. So here we can deal with solution, solvent, solute as well as the types of solutions. Almost all processes in the body occur in some kind of liquid solution, right? So this is all about what it's mentioned in your textbook. So all the process in the body is mostly occurring in the liquid solution, right? In our life, we rarely came across pure substances. Most of these are mixture containing two or more pure substance. For example, the sugar solution, saline, etc. All these are the mixture containing two or more pure substance. So in the sugar solution, we have the sugar water. Saline water, we have the salt, common salt as well as sodium chloride as well as water. Their utility or importance in life depend on their composition. For example, the property of the brass. Brass is what? It is a mixture of the copper and zinc. So brass is a mixture of copper and zinc. German silver, copper, zinc plus nickel. Bronze, copper and tin. All these are compounds of copper, but brass is quite different from German silver or bronze. Even though each of them has the copper as the main ingredient and they also have some other compounds, right? So because of that, they have the different property. Another example is about the fluoride. You know, the fluoride toothpaste and all. 1 part per million. That is a 1 ppm of the fluoride ion in water prevents tooth decay. So, how much should have the fluoride? How much fluoride should be there in our toothpaste? Only 1 ppm. This will prevent tooth decay. But if it is about 1.5 ppm, too much fluoride, it will mottle the enamel. So that is not good for our tooth. Next is high concentration. Even more higher ppm. What happened? It is poisonous. For example, in the rat poison, sodium fluoride is there. It is in higher concentration. The fluoride is in higher concentration. That is causing the death of the rat. Even it is poisonous to us. Okay. So even the amount of the component in each is a special result in the special character of that feature. So there is merits as well as demerits according to the composition of a component in a mixture. Now next, intravenous injection. You might have heard about the IV injections. These are also always dissolved in water containing salts at a particular ionic concentration. So they match with the blood plasma concentration. So when they are getting into our body, it should match the blood plasma concentration of our body, right? So, okay. So if we are just putting this medicine in the water, just pure water, it is wrong. If it is too much salty, that also wrong. Isotonic, that means it should be containing the salt at a particular ionic concentration that is matching our blood plasma concentration. Then only IV injection should be correct. So in this unit, we will consider mostly liquid solution and their formation, also followed by studying the property of solution like the vapor, pressure, colligative property. So let's begin with the types of the solution and the various alternative in which the concentration of the solute can be expressed in the liquid solution. So we can first study about the solution. What is solution? Solutions are the homogeneous mixture of two or more than two components. So homogeneous mixture means they are uniform. After mixing, it should be uniform. Right. So sugar plus water, sugar solution. So that is sugar is mixing in the water thoroughly, then become the sugar solution. So solutions are the homogeneous mixture of two or more than component, more than two. Two or more than two. That can be referred to as the solution. By homogeneous mixture, we mean that its composition as well as the property are uniform throughout the mixture. For example, sand and water. It is not making a solution because why? The sand will not mix with water thoroughly or uniformly, right? So homogeneous mixture means the composition as well as the property should be uniform throughout the mixture. Next is a solvent. What is a solvent? Generally, the component that is present in the largest quantity is known as solvent. So, in case of the sugar solution, we are not taking sugar and water in the equal amount. Water will be more. So, the sugar dissolves in water, and here water is the component that is present in the largest quantity. So, we can call the water as a solvent. The component in the largest quantity determine the solution state. So, water is in which quantity? Which state? It is in liquid. Sugar is solid, but the water is a liquid, and the water is in the more concentration or more quantity. So, the water is that which determine the state of the solution. So, the solution will be liquid. Solvent determine the physical state in which the solution exists. So, in the I told in the sugar solution, sugar is less, water is more. Water is liquid, sugar is solid. So, liquid content is more quantity. So, the liquid will be the solution. Now, copper mixes with zinc. Copper mixes with zinc we studied in the brass. So, here we saw brass, copper plus zinc. So, here copper and zinc both are solid and copper is more here. So, the solution we can see is copper. That is, that which is in large amount or quantity we call as a solvent. So, here the solvent is copper and it is in large amount. So, the solution is solid. So, by the term solution, don't think only liquid state. We can say there is a solid, liquid as well as gas solutions are there. Clear? So, solvent determine the physical state in which the solution exists. Now, next is solute. One or more component present in the solution other than solvent is called the solute. So, in case of the sugar solution, we have sugar as well as water. So, water is in the large quantity and that we call as solvent. The other quantity which is less, we can call it as solute. The other component present in the solution other than solvent. So, if in this mixture we have sugar, salt, food color, all these are solute. Why? Because water is the solvent here. All other component we call it as solute. So, solvent, the component in the large quantity, we call it as solvent. Solute is the component present in the solution other than solvent. Solute plus solvent gives the solution. And how the solution appear? What is the texture of the solvent? What is the physical state of the solvent? That determine the solution physical state. Clear? Now, in this unit, we shall consider only binary solution. So, what is binary? Bi means two. So, usually consisting of two components. The solution containing two components, we are dealing only two component solution here, binary solution. So, here each component may be solid, liquid or in gaseous state. So, we can study. Types of solution. So, usually we can say there is a gaseous solution, liquid solution as well as the solid solution. So, there are three types of solutions. Gaseous solution. So, gaseous solution, what is? Gaseous solution means what, how this physical state is there, how it will appear, the solvent, which is the physical state of the solvent determine the gaseous, solvent determine the state of the solution. So, first example, gaseous solution. Here, the solute as well as solvent is in gas. If both gas, then what happen? Automatically, it will be gaseous solution. Here, the solvent is the oxygen gas. So, solvent is that one determine the state of the solution. So, solvent is the oxygen gas. So, mixture of oxygen and nitrogen gas. Next, solvent is again, here we are gaseous solution means solvent will be always gas. So, here is nitrogen gas. Solute is liquid chloroform. Even though the solute is liquid, here the solvent is gas. So we get always a gaseous solution. So for an example for that is chloroform mixed with nitrogen gas. Next is camphor in nitrogen gas. Again, the solvent is nitrogen gas. Solute is solid camphor. Solvent, if the solvent is a gas, again the solution will be gas, camphor in nitrogen gas. Next is liquid solution. So here what will be the solvent will be the liquid always. Oxygen dissolved in water. So here water is a liquid, oxygen, the solute is a gas, solvent is a liquid, solute is a gas. So solvent, the state of the solvent will be the state of the solution. So that is liquid. Next, water, both liquid. Solute is ethanol, solvent is liquid. Both are liquid. Still, the state of the solvent is that which determines the state of the solution. So that is liquid solution. Next, glucose dissolved in water. You know, glucose is a solid, right? And again, the solvent is water. So this solution is also liquid solution. Now, solid solution. So, solid solution, what will be the solvent will be solid. Solvent will be solid. Solvent will be solid. So, if you understand the concept, the others will be easy. So, solid is that, solvent is that which determine the state of a solution. Hydrogen in palladium. So, you know what is hydrogen? It is a gas. Palladium is a solid. So, here the solvent is palladium. So, here this we can see this is the, here the solvent is the solid palladium. So, what type of solution it will be? It will be solid solution. Next, amalgam of mercury with sodium. So, you might have heard of amalgam. Amalgam of mercury with sodium. So, here the mercury is a liquid state. That is a solute. But what about the sodium? Sodium is in the more amount. So, sodium is a solvent and sodium is solid. So, again, this will be a solid solution. Copper dissolved in gold. So, copper is a solid, gold is a solid. Solvent is gold, solute is copper, but still, both of them are solid. Still, the solvent here is a solid gold. So, solvent will be more. So, this will be a solid solution. Okay. So, this is the summarization of the what we have studied. So, what determine the state of a solution is the solvent. So, when it is gas, solvent is gas, it is gaseous solution. Solvent is liquid, liquid solution. Solvent is solid, solid solutions. Okay. So, hope this is clear for you. So, thank you for watching my video. Please like, share, subscribe my channel. Any doubt you can post in the comment section. Thank you.